Today we are going to solve Codeforces round 151 division 2 second question, that is come together. So here is the question. Bob and Carol hang out with Elise the whole day, but now it's time to go home. Elise, Bob and Carol live on an infinite 2D grid in cells A, B and C respectively. Right now, all of them are in cell A. So all Elise, Bob, and Carol are in cell A currently. There are three cells on a 2D grid. Okay, A, B, and C. And currently, Elise, Bob, and Carol are in cell A. Okay, and B and C want to go home. If Bob or Carol is in some cell, he, C can move to one of the neighboring cells. Two cells are called neighboring if they share a side. For example, the cell 3, 5 has four neighboring cells 2, 5, 4, 5, 3, 6 and 3, 4. Okay, so basic thing is the neighboring cell of this, suppose the neighboring cell of this red one is this 4 yellow one. Okay, so Bob and Carol can go through these 4 from A, that is from red one. Okay, this is the thing. So Bob wants to return to cell B and Carol to cell C. Both of them want to go along the shortest path, that is along the path that consists of minimum possible number of cells. But they would like to walk together as well. Okay, so Bob has to go to cell B and Carol to cell C, and they have to go together also and through the shortest path also. Okay, so what is the maximum possible number of cells that Bob and Carol can walk together if each of them walks home using one of the shortest path? Okay. So we have to print the maximum number of cell up to which Bob and Carol are together. Okay, so it is easy. Let's check the code. Suppose this red one is A, this blue one is B, and this green one is C. Okay. Let's write it down here that red one is A, blue one is B, and green one is C. Okay, so now look, previously all the three A, B, C are here in cell A. Now Bob will have to go to blue one and Carol have to go to green one. Okay, so you can easily see that only two cases are possible. Suppose the two cases are that one, that this red block is in between blue block and green block. Okay, the basic thing I want to say that the blue one and green one is either the same side of red one or in the opposite side. Okay, these two cases are there. If suppose this case is there, that if this both are on opposite side, blue one and green one, then shortest path is what? Blue will go like this way, and Miss Bob will go like this way, and Carol will go like this way. Okay, one more interesting thing is that if you travel along the path from red to blue, then you can choose any path. All the paths are shortest one. Means inside and along this rectangle. This rectangle. Okay. So yes. So you can easily see that Bob will Bob will go through this way. Bob will go through this way, and Carol will go through this way. Then only in this case, how many cell are there which are in common? Only one cell, this red one. So in case 2, our output will be 1. our output will be only 1. Okay, but in this case that if both blue and green one are on same side of red one, okay, either this or this, okay. So in this case how will we calculate? So let's check it. Look, Bob and Carol start from red one and go like this, okay. And from here Bob will go in this direction and Carol will go in this direction, okay. So how many common blocks are there? This and this one, and this red one is also common, okay. So total 4 common cells are there, okay. So how will we will calculate this? So we will calculate like this. Firstly we will calculate distance from red one to blue one. So how many blocks are there? 1 2 3 4 5 6 7, total 7 blocks are there from A to B. So from from A to B, 7 blocks are there, 7 cells are there, okay. Now from A to C, that is blue to green, how many cells are there? 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So from A to C 8 cells are there, okay. From A to C 8 cells are there, and from B to C from B to C how many cells are there? 1 2 3 4 5 6 7 8. Here also 8 cells are there, okay. So what we will do is, look here, if we will sum up this road, okay, this road, this one, okay, and this one, if we will sum up this road and this road, then if we will sum up this path and this path, then this block, this block, this block, and this block sum up 2 times. Understood now? If we will sum up this path and this path, okay. If we will sum up this path and we will sum up this path, then these four blocks will be sum up 2 times, okay. And in that summation, if we will subtract this path, if we will subtract this path, then whole this thing will be clear, and this will be remain in the sum only one time. So how total what will be done? This cell remains 2 times, this cell remains 2 times, this cell remains 2 times, but this cell remains only one time, okay. So our net summation will be what? Our net output will be what? We will print this by 2 and this plus 1, okay. Like what? We will sum like this. We will add S equal to AB, S equal to AB plus AC. Okay, and in this we will subtract BC. What we have done? We have add sum of AB, means path of AB and path of AC. Okay, and in this, from this we have subtracted BC, path of BC from B to C. Then in this summation, how many cells are there? This red one and then this three one. But from this three yellow one, only this one is only one time. Rest of this one is two times. Okay, rest of this one is two times. So what we will do now? We will do like this. Then we will calculate. Suppose R equal to S minus 1 by 2. Okay, and in this we will add plus 1. Understood? This is a basic code. So yes, this is our output in this case. In the first case, this is our output, and in the second case, output is 1. I hope you understood this logic. Then that we will sum up this path and we will sum up this path. In those, we have subtracted this path, and now we have calculated the common path from this logic. Understood? So let's check the code. One more thing is that how we will means check these two cases, means how we will declare these two cases. So look here, in from red to blue, how many cells are there? 1 2 3 4 5 6, total 6 cells are there. And here how many cells are there? 1 2 3 4 5 6 7. So 6 cells are from red to blue and 7 cells are from red to green. So write down here. So what are the total path? Total cells in the path? 7 plus 6. Okay. And in 7 plus 6, this red one is common. So minus 1. Okay. This is the total path. If we have sum up this and this. And now check from B to C total path. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So here it is coming 12. So 7 plus 6, 13, minus 1, 12. So yes, both of them are correct. So we will do like this. So let's check the code. Okay. So look here. Firstly, we have taken input test case, and then we have taken input the coordinates of A, B, and C. This x1 comma y1 is coordinate of A, x2 comma y2 is coordinate of B, and x3 comma y3 is coordinate of C. Okay. So what we will do is firstly calculate distance between AB, distance between AC, and distance between BC. Okay. So we have declared three counters AB, AC, and BC for distance. And how we will calculate distance between B and C? So absolute difference between x coordinate plus absolute difference between y coordinate. Okay. So absolute difference between x coordinate plus absolute difference between y coordinate minus 1 plus 2. You can easily understand this from this figure. Okay. Try it once. So similarly, from A to B, we will calculate absolute value of x2 minus x1 plus absolute value of y2 minus y1 minus 1 plus 2, like AC. Okay. Now we have already discussed that only two cases are there. The first case is if if this thing, distance between A and B plus distance between A and C, is equal to distance between B and C. Okay. So if BC equal to distance between B and C equal to AB plus AC minus 1. then our output will be what? Our output will be simply 1. Okay, only red one is common in this. But if this case is not, then our output will be what? We will sum up distance between AB and AC, and we will subtract BC, means distance between BC, and then our output will be what? This R minus 1 by 2 plus 1. Okay, I hope you can easily understand this. Still you have any doubt, then you can ask in the comment section below.